We'll get started. Welcome, everyone. On behalf of Mid-Columbia Fisheries, I really appreciate you taking time out of your life to be with us today. This is our final offering in our 2022 Winter Speaker Series. We have been thrilled at the turnout for all of our talks, and we really look forward to continuing to offer these types of educational offerings in the future. I'm Merritt Mitchell-Wajee. Some of you know who I am. I'm Communications and Outreach Manager for Mid-Columbia Fisheries, and I get to be honored to be the MC this evening. And I'm joined by Zach Zakavish, who's also Mid-Columbia Fisheries, who some of you also know, who's helping to manage our online technology, which is always fun, and questions tonight. So thanks so much to Zach. And then I'll get to introduce the speaker du jour in a few minutes, who you also many of you know. For those of you that are new to Mid-Columbia Fisheries, our mission is as follows. We are a not-for-profit organization dedicated to protecting and restoring wild salmonid populations and their habitats through restoration, protection, education, and community involvement throughout our region. Mid-Columbia Fisheries is a part of a statewide network of regional fisheries enhancement groups. There are 14 in the state of Washington, dedicated to restoring and protecting salmon habitat. And we work with landowners in South Central Washington's Columbia Basin, including the Yakima, Kittitas, white salmon, and Wind Rivers. I'd also like to give a shout out to several of our board members, past and current, that are in our audience this evening. And if you are so willing, put your cameras on so everybody can see you. And again, thank you for all of the work that you do to make our work possible. So we have Dave Boutte, John Easterbrooks, anybody that I'm missing that I don't see? And Sherry Penny, who is a recently retired board member, but she's here somewhere. She was here.
Thanks for coming and supporting the talk.
One of the benefits of a virtual presentation allows us to bring together folks from a larger area. And for that, we are grateful. We are ever so hopeful we'll all get back to some normalcy in the near future. But this is fun because we get to see people we don't always get to see. So on with the show. It's my pleasure to host this session titled Cottonwood Establishment in the Yakima Basin, What We Are Learning for Fish. Our speaker tonight is one of our own, Katrina Strathman. Katrina is a restoration ecologist with Mid-Columbia Fisheries. Her current passion is riparian forest restoration and using new techniques that improve establishment or are effective over large floodplain areas. Katrina brings her work of over 23 years of experience managing ecological restoration projects in a wide variety of habitats, as well as landscape scale inventories, vegetation monitoring, invasive plant and rare plant management, and native plant propagation. Now, Katrina previously worked on ecological restoration for the Yakima Nation and for the National Park Service. She received her MS in biology from San Francisco State University, studying local and landscape influences on butterfly assemblages in mountain meadows of the Sierra Nevada. And tonight, Kat's going to be highlighting the work that she's been leading to better understand the forces at work with the primary riparian forest tree in our region, black cottonwood, and its critical role in maintaining river processes and salmon habitat. So Kat will share results of a recent assessment of riparian forests in Kittitas reach of the Yakima River, and the presentation will include threats to these important ecosystems and restoration opportunities. So a little housekeeping before we begin. Hopefully everybody's on the right talk today. We will be happy to take your questions at the end. You can also put your questions in the chat. And so through the duration of the presentation, we're going to keep you muted, but you can unmute yourself during the question period. And then in terms of the screen, you can change the screen so you're just seeing who's presenting, if you so desire. Upper middle section where it says view everyone, there's some little up and down arrows. You can just change it to whoever is currently speaking. And then if the presentation size is too small, there's a little plus sign on the screen to enlarge what you were seeing also. We will be recording tonight, so you can revisit this and all of the series presentations on our YouTube channel. If you haven't subscribed to that, let me know. I can get you the link, or you can look up Mid-Columbia Fisheries on YouTube and find a lot of interesting content. And without further ado, I turn it over to Kat.
Great. I'm going to set up my presentation. Can you all see that screen?
Yes.
Yep.
Okay, super. Thank you. Well, I am really glad to be here with you all, talking about a piece of the river ecology puzzle that I am really passionate about, which is cottonwood forests, or riparian ecology. But specifically tonight, I'm going to be looking at the status of black cottonwood forest on the Yakima River. And first, before we get started, I wanted to acknowledge that I'm presenting work and results from efforts of numerous people and organizations, including the Columbia Fisheries field staff, Yakima Nation staff, natural systems design colleagues, and many partners and landowners. So this work really is a large collaboration. For those of you that aren't as familiar with Mid-Columbia Fisheries, we work in 5 counties that are shown here that includes the Yakima Basin. And this project is focusing on the Kittitas Reach, this area up here, part of the Yakima River. So that's what we'll be focusing on tonight in the Yakima Basin. Previous work by the Yakima Nation looked at cottonwood forest condition and reproduction on the Wapato Reach down here, but I'm not going to be talking about that, that work tonight. It would be fun to combine both tonight's talk and the Wapato Reach work into a single talk at some point. So why am I talking about cottonwood forests? For those of you that aren't kind of deep in the weeds of riparian ecology, just wanted to share like the basic nuggets. So why am I so impassioned about this? Black cottonwood are a foundational species in arid western floodplains. And we know from the literature that there are losses of riparian forest and degradation of riparian forest condition happening on regulated rivers all around the West. So what's happening in the Yakima Basin is not a singular thing. We also know that climate change is probably going to be making this worse because of increased drought stress and changes in the flood regime. So knowing that there may be stresses, we really wanted to look at conservation measures for riparian forest, looking for kind of large-scale, cost-effective solutions and also small-scale solutions. So tonight I'm going to be talking about, and I'm going to pause for just one moment and make sure that I know what time it is as we move along here. So I'm going to be getting us all on the same page again since we come from many different backgrounds, and talk just a little bit about riparian forest function before talking about cottonwood regeneration and forest regeneration, and then spend some time going over the results that we have from our assessment in the Kittitas Reach of the Yakima River. And then, unfortunately, due to time constraints, I'm not going to be presenting information on future restoration and some of the restoration methods that we can use, which is really exciting. But in the interest of time and wanting you guys to go to bed at a reasonable hour, I'll talk about that another time, where you can contact me if you're really excited about that topic. So what do cottonwood do in our riparian ecosystem? Their dense roots slow that natural erosion that happens, so they're providing some bank stability. And during flood flows, during surface water flows, those stems and trunks really act to roughen the ground surface, slowing water down, allowing sediment to drop out. Those large tree canopies also create shade and decrease water temperatures. And then leaf litter and wood debris fall into the river and provide a source of nutrients for aquatic insects that in turn are food for fish. But one of the coolest things that I think from a plant ecology perspective are neat about cottonwood is that as a source of large wood in this system, they fall in the river and they help to create complex aquatic habitat for fish. And simultaneously, they create bars, they degrade sediment that then becomes the very recruitment sites for the next generation of cottonwood. So here you're looking at the Big Wood River in flood, and you can see that cottonwood trees have fallen in. You can even see some of those root wads that are beginning to erode new bars, so they're capturing sediment. And they're also directing flow that's causing channel movement, so it's causing directing flow to erode banks on one side of the channel or the other. And even during typical flows, this flow direction can cause the river to migrate and erode sediments from one side and then deposit them on another area, creating bars and sediment on channel margins. And those bars and channel margins are then potential cottonwood recruitment surfaces. So these are all potential recruitment surfaces being created here in this image. As are low elevation area, open areas where sediment is deposited during large surface flows. Getting to cottonwood biology, we know that cottonwood reproduces sexually and vegetatively, sexually meaning by flowers and fruits. It's also a dioecious tree, which is just one of those cool things in the botanical world where there are male plants and female plants, with male plants having male flowers and female plants having female flowers that develop into catkins, like the female catkins seen here. There are other organisms that flowering plants that have male and female flowers separately on the same plant, or even male and female flowers parts in the same flower. So anyway, all different kinds of things, but this is kind of neat about cottonwood. We've been looking at cottonwood seed release, and here's that cottonwood fluff being exploded out of these catkins as they, or seed pods in the catkins as they ripen. So we've been looking at the timing of seed release in the Kittitas Valley, and are finding that peak seed release looks like it's happening in the latter half of June. So we're still working with the Yakima Nation to nail down seed release timing. We also know that seed viability is really short. It's high for about a week after the seed is released from the catkins. And then once it gets wet, that viability declines really fast, starting within 24 hours of the seed getting wet. So in a nutshell, the seed needs to hit the right spot and quickly. So in terms of vegetative reproduction, which means clonal reproduction or resprouting, most of that is occurring in openings within established tree stands. And that's really the mechanism. This clonal reproduction is how existing stands self-maintain. So vegetative reproduction, like what you're looking at here in an established tree stand on one of the geomorphic reaches in our project area, if that reproduction is not happening, those old cottonwood stands will eventually die out and will be replaced by other species. So now we're going to look a little bit more closely about how sexual reproduction or seedling reproduction from seed happens. And I wanted to start by saying that seedling production is episodic. So although our trees may flower and produce seed every year, those forest stands that are created, or the seedling seed beds that occur, are episodic. So they only happen when several key events coalesce. And so what we see really are seed establishment pulses for cottonwood regeneration. So I'm going to try to explain that through this stylized hydrograph. And it's a hydrograph, or essentially a graph of a water calendar year. So you're looking at the relative elevation of water relative to the bank elevation on the y-axis and time on the x-axis. And the blue line here is corresponding to the height of flow, or the flow volume, and over time. So this stylized hydrograph is for an unregulated river, meaning that the river is not dammed. Flows and flows that we're looking at are based on unmanaged precipitation and snowmelt, unlike our managed rivers that are, the Yakima River is managed for irrigation, so it's dammed, and flows are released on a different time scale than unregulated flows. So this model that we're looking at, this stylized hydrograph, is known as the Recruitment Box Model, which was coined by John Stella, and it is a way of thinking about this cottonwood recruitment event that has really held true in cottonwood systems all over the West. So it's widely known within the riparian ecology world. And so here we go. I'm going to try to lead you through this. Cottonwood require 4 conditions to establish from seed. And this recruitment box here in the stippled gray represents where all of these conditions coalesce in time and space. So the first condition that they need is sufficient bare, moist soil, which is created by large winter or spring floods, represented by this high, this peak flow here. So this is a scouring and deposition event that's creating these new bars, depositing sediments on the floodplain. The second thing that they need are flows that at the time of seed release here are high enough above the level of summer base flow, so they're not going to be inundated in the summer, but they're low enough to be able to access summer base flow. So it's kind of a sweet spot. So this flow recession happens and keeps those seed recruitment sites moist and seeds released. And then the third thing that they really need is a flow recession after seed release that is very slow. So a gradual decline in flow that does not outpace the decline of the water table, because those seedling roots need to develop at the same rate that water is declining, and that's about 2 inches per day. And then the fourth thing that's not shown on this model is that these seedlings need to be established at a high enough level, elevation on the floodplain, that they escape subsequent scouring flows or inundating flows in floods for 1 or 2 years after establishment. So as you can see, all those things need to come together to allow a stand to be created, which is why a stand isn't created every year. On average, we're seeing in natural systems that happens between every 5 and 10 years. So now you're looking at what's really happening in the Yakima River. This is discharges from at Cle Elum, and the black line is modeled unregulated hydrograph, so a water year graph of what conditions could be like at Cle Elum based on the precipitation that we've gotten if we didn't hold back water in the dams and release it for irrigation. So what you're seeing here are some peak high flow events on average, and these are actually tamped down because these are averages happening in the winter and then in big floods in the spring, followed by a flow recession with base flow hitting about August. So that's what would be happening in an unregulated Yakima River, ostensibly, according to this model. The blue line is representing the average daily flow that has occurred. And what we see is that these peak floods are really tamped down. Again, this is average, so you're not seeing the peaks that you would see if we laid each year over itself onto a single graph. But we're not seeing any real big trends in peak flood flows during spring and summer. And then in this recruitment box area, during winter and spring, in this recruitment box period when seed is being released, we're also not seeing that flow recession. In fact, on this section of the Yakima River, flows increase as water is released for irrigation and then drops abruptly at the end of the summer season over the first 1 or 2 weeks in early September. So seedling recruitment sites are being inundated after seed release, and then trees are stressed as there's still fairly high evapotranspiration rates in early September when we have drops in available groundwater. So what does successful sexual regeneration look like on the landscape? And here's an image from the lower Natchez River, which is still regulated, but it's a moderately regulated river. So we still are experiencing a lot more flooding on the Natchez than the Yakima River. And what we're seeing is a lot of bars, so a lot of active floodplain development. And then the other thing that is good for us to train our eyes to is the diversity of age stands. And we were able to, actually Tom Elliott did this by looking at, he aged the estimated year of establishment by looking at aerial imagery, historic aerial imagery. So we can see that some of these stands are more than 30 years old, and some are only 10 or 15 years old, with seedlings recruiting on these bars. If we were standing right here and doing a Google Earth street view, here's what this looks like, is looking out over the floodplain. We can see these young 10, 15-year-old seedlings and saplings establishing on bars, and then those mature trees. So we've got a wide variety of size and age classes. And this is another look at that across the river, where the youngest trees have established closest to the river margin on the newest, most recently created substrates. And then further away on those older substrates are the older medium-sized trees, and on the oldest floodplain are the older trees. So definitely establishing in often in linear form. This is an historic aerial image from the Kittitas Reach before the I-90 was installed, and you can see the channel scars on the floodplain, and also this different, the linear formation of the forest stands, and also those different tree ages over the landscape. It's fascinating to look at how this worked, and also a lot of bar development down that river. Okay, so continuing on our cottonwood story, we know that cottonwood lived for 100 to 120 years in our age. And we also know that, like many organisms, seedlings should dominate the age classes, so that a stand age distribution should show a lazy J-shaped curve, like what we see right here in Wilm's study in Alberta, where his age distribution, you're looking at the proportion of trees that he observed and the estimated year of establishment on the x-axis. What he found is that roughly 70 to 80% of these trees are less than 10 years old, and the rest of them have a fairly even distribution, especially after you get more than 20 years old. So Jeff Brotney and his colleagues they looked at cottonwood age distribution in the Yakima, in 3 reaches of the Yakima River in the early 2000s as part of the Reaches project. And what they found was fairly troubling, and is one of the reasons that both the Yakima Nation and Mid-Columbia Fisheries has gotten involved in trying to understand what's going on with cottonwood forests in on the Yakima River, is that their transects estimating age distribution showed that there was no recruitment for the last 20 years, which is really a troubling finding. And they also showed that there's a lot of trees that are about 50 years old, and then, but those are going to be moving into older age classes. So without replacement of those trees, there's a potential for those trees to, for the forest to age out. So that is what precipitated our beginning a forest assessment on the Kittitas reach of the Yakima River. And the goal of this assessment was really to understand the threat of riparian forest loss due to river regulation and floodplain land use, and then figure out what we can do about it. And as I said earlier, I'm really sorry that I won't have time to talk to you about what can we do about it and what we're planning right now, but I did want to share the results of this study with you because it's been underway for about 1.5 years, and we're really excited to be wrapping this up and sharing it. So we asked 4 questions in this assessment. The first is, what's the current extent of riparian forest? Is that forest generating adequately for stand replacement as forests age and die? What is the condition of the existing mature forests, and are the forests that we have at risk? And then we also are looking at where are opportunities to increase regeneration in forest extent. As I said, that last question we won't be getting to tonight. So starting with, what is the current extent of forests in the Kittitas Reach? And I guess I want to start by just defining that reach. And so we're looking at 30 miles on the Yakima River in the Kittitas Valley, starting in the upper valley at the confluence with the Tianaway, in the canyon after the confluence, down through the Kittitas Valley and at the entrance to the Yakima River Canyon. So that 30-mile river mile 176 to 146. And so to evaluate the extent of forest and our reach, we used the channel migration zone for the Kittitas Valley. And just to define terms, the channel migration zone is an area where the floodplain, in a floodplain where a stream or river channel can be expected to move naturally over time. And channel migration, I want to point out, is a natural process, and it can occur steadily as that annual process of erosion and deposition on a river, or it can happen really fast, as like during a flood that carves a new path for a river or stream. So we use this defined channel migration zone, which was done in a study for Kittitas County. And our partners at Natural Systems Design identified 6 geomorphic reaches and delineated them in the project. And I'm going to just review this really rapidly so that I can save time for other things. But the first thing I wanted to say is that Reach 1, which is the confined canyon reach, doesn't have any digital elevation imagery associated with it. So we weren't able to do some of the geomorphic analysis that we did on the other reaches there. But in reaches 2 through 6, we did have that imagery. And in general, the pattern that we see in the reaches is that reaches 1 and 2 are very confined. 1 in a canyon, 2 between a hill slope and a very high glacial outwash terrace. Reaches 3 and 4 are moderately confined, but they were less confined historically, and now they're actually quite confined in current day conditions. And then there's a broadening of the floodplain into reaches 5 and 6, and 5 has more anthropogenic features that confine the river, although the channel migration zone is wide, and then reach 6 is kind of our broadest, most dynamic reach of the river. Okay, so the NSD, Natural Systems Design geomorphologist that we worked with, used a relative elevation model to characterize geomorphic surfaces in the channel migration zone. And this is an image depicting what those features are. So he basically identified low flow channels, these developing or establishing floodplains, which are the vegetated gravel bars, side channels, the established floodplain, which is only inundated at frequent flood flows, and then terraces, low terraces that may be inundated at 100-year events, and then upper terraces that are really not inundated anymore. One thing I wanted to point out is that this graphic does not include disconnected floodplain features, which are a big piece of the geomorphic assessment. And those would occur here, but they would, again, they would have some type of anthropogenic feature like a road or levee that is disconnecting that surface from the flood, from flood events. Okay, one other thing I wanted to point out was that we intentionally placed transects that we used to sample the forest on establishing and established floodplains. So we really intentionally wanted to select these gravel bars because we were trying to capture what was going on with sexual reproduction. So remember that. I'll talk about that again as we work through this. So the channel migration zone is extremely limited. This is what we found. We know this going in. It occupies about 11.4% of that 13,800 acres of the CMZ are these developing or established floodplains that where cottonwood are predominantly occurring and can be created. And about 70% of the CMZ is disconnected floodplain. These disconnected floodplains, terraces, or infrastructure that is not being accessed regularly in flood flow. So they're not dynamic parts of our system anymore. One thing that I wanted to point out that gives me a little hope as a restoration ecologist is that 27% of the channel migration zone is disconnected floodplain, which means that there may be opportunities in key locations where it's possible to remove constraining features and reconnect floodplain. So here's what we know about forest. One of our technicians that worked with us for a year, and I was really hoping she might be here tonight, Marissa Louie, typed forests for us along this 40-mile reach by visually using remote sensing and characterizing the forest as either closed, open, woodland, or scrub, and in our channel migration zone. So now we can see that about 23% of our area is currently forested. Interesting to note that of these disconnected floodplains and terraces, those areas that are not hydrologically connected to the river anymore, at least in terms of flood events, only 3.1% of those areas are actually forested. So they've definitely moved to other uses. Most of our forest stands are mature. Over 60% are open or closed, and then the rest are in the other categories. This is that aerial image when we're talking about confinement and the state of forests right now. This is that aerial image that you were looking at, and this is the same reach with I-90. So when we're talking about a floodplain being constrained on the right bank, and flow is going from left to right here. So on the right bank, the river is naturally constrained by a high glacial outwash terrace. And on the left bank, it's now further constrained by I-90. So it's really got a pretty narrow band to move within in that area. Okay, let's move to how is the forest regenerating adequately? What does regeneration look like in our forest? So we were through our assessment, we were able to understand what is going on with age distribution. And again, we did attempt to capture primarily what was happening on developing floodplains with our transects. So when we're looking at this age distribution, we need to understand that sexual reproduction on our reach is probably overrepresented. We're probably seeing a better picture here than what exists if we had randomly placed our transects across the entire reach. But it does help us to understand how much is happening and what those dynamics are, which was our purpose. So right now we're looking at not the age distribution, excuse me, but the diameter distribution. And seedlings are in the 0 to 2 centimeter diameter class. We grouped legacy trees into a single age class because we can't core accurately trees over 50 centimeters in diameter breast height. You can't get a readable core from a large tree. So even though we can see that nice age distribution here when we look at diameter classes, for purposes of talking about what we actually know about the trees, we grouped them, and that's what this looks like here. So now you're looking at the number of trees, again, on a log-based 10 scale on the y-axis, and age in years in 5-year bands along the x-axis. Note that seedlings are all grouped in a 0 to 12-year age class. So not only are we probably overrepresenting them because of the way we sampled, but this age class is actually representing 2 or 3 seedling age classes here. First thing I wanted to say about recruitment is that these seedlings here that represent 0 to 12 years. So I would argue that they're actually not all seedlings, that some of them are older trees, they're just very skinny. They represent 33% of all trees, which is a lot of trees. But if we look back at Wilm's study in Alberta, 80% of his trees were less than 12 years old. So we really should be seeing a preponderance of trees in this age class here, and we are not seeing that. So another way that we can look at this is by aggregating our trees into general age categories of seedling, pole, overstory, and legacy. Again, the legacy being those very large, older trees, overstory being mature trees, pole being trees that are between roughly 15 and 25 years old, and the seedling in that 0 to 12-year-old category. So what we can see here, it becomes easier to see that cottonwood regeneration is episodic, and that it's been probably at least 12 to 15 years since we've had recruitment events that are substantial. So that's one way of looking at this data. I wanted to look at what within reach patterns are, because it makes me ask some other questions about this. So here you're looking at the percent of trees within each reach in each of those 4 age class categories. So for example, within reach 1, you've got the percentage that all total 100% of each age class category within that reach, and so on for each of the other reaches, so that we can see how each what the distribution is within each reach. So our dynamic reach 6 looks like it had large recruitment event or events 13 to 18 years ago, because that's where all of our poles are. And reach 3 had some prolific seed recruitment events less than 12 years ago. And I did sample one of these transects. So I think 1 or 2 of our transects picked up a lot of these trees. So one of the things that I'm left asking about these recruitment events is, how do we know if these pulses are sexual in origin? Are they regeneration and happening on the channel margin, part of the fluvial process and creating new forest? Or are they clonal in origin, where they're basically these self-maintaining with regeneration within the existing forest? So let's look at 3 of the reaches a little more closely and see if we can tease that out. So here you're looking at reach 6, our most dynamic reach, and these white bars along the reach correspond to where we had our transects placed. Again, this is the most dynamic reach at the lowest position of the Kittitas Valley before the river enters the canyon. And it's really broad, well-connected floodplain. It has a lot of these green established or establishing floodplains. The developing floodplains, which are a lot smaller, are shown in gray, kind of light green here. So they are present on this reach. There's a lot of disconnected floodplain, even not disconnected by Canyon Road and the railroad that runs through the valley. So what do we know about forest recruitment within this reach? So I'm showing you a couple of graphs that show for each individual tree, its relative elevation and also its position horizontally relative to the channel margin. So this y-axis is the relative elevation of each individual tree relative to water surface. And then the x-axis is the position on the floodplain, with 0 being the channel margin, and then as we get further away, it's the meters away from that channel margin. So we would expect to find sexually generated seedlings and poles either establishing near the channel margin or at low elevations where sediment have been deposited on the floodplain. So what we're seeing in Reach 6, and then we would expect that clonally generated seedlings and poles could occur really at any distance from the river or relative elevation, but they would not be necessarily, those clonally regenerated seedlings don't necessarily have to be regenerated next to the river margin. So in Reach 6, there are a lot of seedlings being generated adjacent to the channel. So we could, which suggests that these, many of these seedlings are sexual in origin. And same with poles over here. So our blue dots on the graph on the left, many of those poles are, look like they originated, they are placed, next to near the channel margin. We also have a lot of poles that are occurring further away from the channel margin, and those poles most likely are clonal in origin. So in Reach 6, it looks as if we have many poles and seedlings that are stand creating trees, so sexually generated trees creating new forest stands, and then we also have some forest maintenance going on, some clonal regeneration in that reach. So overall, relatively good shape. Here's what that looks like. Here's a developing gravel bar with seedlings and a side channel. It's really a diverse active reach, even with all that reed canary grass. So let's contrast that with Reach 2, which is moderately confined. It's also our shortest reach. And again, here where the placement of the transects, the green corresponds to developing floodplains, beige and brown correspond respectively to those low elevation and high elevation terraces. So we definitely got a confined reach here, the glacial outwash terrace on the right bank, so the direction of flow again from left to right. On the right bank, that terrace, and on the left bank, that hill slope, pushing that, confining that floodplain. And here's what we're looking at in terms of that geomorphic position of seedlings and poles. So for seedlings in the right graph, they're distributed all over the floodplain and all over elevations, all the way up to 2.5 meters above water surface, which we're using as a rough estimate of groundwater. Tom Ring can argue with me about the validity of that later. And we're seeing the same pattern for pole creation across the floodplain and at various elevations, suggesting that poles and seedlings are primarily clonal in origin on Reach 2. And here's what a typical stand looks like on Reach 2. It's very single-aged. And from sampling those, there is a lot of within stand recruitment visible. So now let's look at another reach, Reach 4, and you saw this image in the historic aerial image. It was historically constrained on the right, but now is further constrained in our current period on the left bank by Interstate 90, and it does include the town of Ellensburg. So there's a lot of infrastructure in this reach of the river. So what we're seeing in terms of regeneration is that we actually have a large number of seedlings that are occurring for the small number that that are present that did occur that occur close to the channel margin. So this suggests that some of our seedlings and some of our poles are sexual in nature, but we've also got a wide distribution of poles throughout the floodplain, so that we could assume that there's also some clonal regeneration happening. This is an image from that reach. It's with a single row of cottonwoods, and you can see the cows through that single row of cottonwoods on that high terrace bank. Okay, you saw this this age class graph earlier, but what I wanted to show is that by examining the geomorphic position of trees, we can make those assumptions about what type of reproduction, whether it's stand initiating or within stand maintenance, is happening. And by examining what was going on in each reach, we saw that there's both sexual and clonal reproduction happening in reaches 3, 4, and 6, 6 being that most dynamic reach, and really primarily clonal happening. Hard to argue that there's sexual reproduction happening in reaches 1, 2, and 5. And those are limited both in recruitment surfaces because of a confined channel, and especially in reaches 1 and 2 that potentially don't support recruitment under the current flow regime. Okay, the last thing I wanted to get into is the condition of the forest. So we know that the majority of stands are older. There 60% of them are in open or closed canopy, so they're mature trees, but are they in good condition? According to Rood and Mahoney, cottonwood crown dieback happens during periods of limited water supply, so that the trees can reduce evapotranspiration and that is supported by the root system. So we measured this crown dieback as potential canopy, and it's an estimate of live canopy in the crown. So we had 4 categories: 95% live or more live being the dark green, down to 35% or less live in yellow. And in these graphs, you're looking at the number of trees in each reach, in each canopy, potential canopy category or live canopy category on the bottom graph. And on the top graph, it's the percent of the trees in each category for each reach. So we can really see how that each reach is performing or what its condition is. So overall, 73% of our trees across the entire Kittitas reach are in good condition, with meaning that they're in this dark green, 95% healthy canopy, not stressed. But 10% of all of our trees are in the moderately to high stress, meaning that 45 to 65% of their crown is dead. And having observed cottonwoods for a while, I would say that that 10% of trees are probably on their way out. We also know that reaches 1, 2, and 5 have fewer trees overall, but of those trees, reaches 1 and 2, the trees are very stressed, and those are also the most confined reaches. 3 and 4 still have a number of trees that are in a concerning level of stress and dieback. And then reaches 5 and 6 have less dieback, 6 being in the best condition. So why are these trees stressed? Remember that we're not talking about, when I'm showing you these graphs, we're not talking about the disconnected floodplain right now. In fact, we don't really know how those trees are doing because we didn't sample them. But for these established floodplains, we do know that the literature in numerous studies shows that cottonwood really are found within 2 meters of the groundwater surface, and they become stressed with changes to groundwater, especially abrupt changes. We also know that, and in our assessment, we found that most trees occur at most of the stress trees occur at the highest elevation above water surface. So their stress is related to low groundwater. Reaches 1, 2, and 5 had the most stress trees, and those trees occurred at an average of 1.5 to 2 meters above water surface elevation. And all of the trees in that reach, in fact, occurred in all of the canopy classes, occurred at greater than 1 meter above water surface elevation. So definitely those reaches are not doing great. Compared to reach 6 with the fewest stress trees, and all of those trees occurred at or below 1/2 meter, within 1/2 meter of water surface elevation. So groundwater's much closer to the surface in that upwelling, that reach of an upwelling zone. Okay, so in summarizing, I wanted to help look at, in one place, what we now know about this reach. And again, conclusions are limited to where we sampled on these developing and established floodplains. The forest extent is extremely limited, as are the regeneration surfaces, the recruitment surfaces. 23% of forests remain, and of those forests, more than 60% are mature. In terms of forest regeneration, 3 of our reaches have some sexual regeneration occurring, and there is new stand development happening in those relatively small acreages, but stand maintenance is occurring in those developed floodplains. Clonal reproduction is happening. I wanted I'll go into that in just a minute and reiterate that. Forest condition is on the developing and established floodplain shows that 73% of trees are in good condition, but some reaches are pretty stressed, and 10% of our trees are at risk of mortality. So when we look at what the limiting factors are to our forest, one of the primary limiting factors is the availability of recruitment sites. Less than 1% of the total area in the channel migration zone supports recruitment sites. But there is the opportunity in key locations to look at removing or setting back infrastructure that could expand the active floodplain and create more recruitment sites. The flow regime is also having an effect of dampening down the magnitude of winter and spring floods that provides those sediment deposition, and creates those surfaces. And those high summer flows are also inundating seedlings. So a spring flow that occurred at a height slightly higher relative to summer flows could help to create more regeneration surfaces. And then finally, clearing for human uses has has really limited our forest extent, and reforestation in key areas where we can create the greatest benefit for our aquatic systems is one of the opportunities, one of the many opportunities that we're pursuing. So, so with that, I just wanted to thank a number of folks. First of all, our field technicians, Marissa Louie, Kirsten Woltersdorf, and Tonya Mori, without whom we would not have this really great picture of what's going on in the Kittitas Reach now. Numerous landowners gave us access to their private land. Really greatly appreciated. We're really wonderful to work with, and I'm indebted to them. The Salmon Recovery Funding Board provided funding for this project, and so it's great that our lead entity and technical advisory group for the Surf Board supported this project. And then finally, the Yakima Nation and several staff people at the Yakima Nation have been involved in this project, as have our colleagues at Natural Systems Design. So a number of people and other organizations and agencies supported the project. But with that, I just want to say thank you so much for being here tonight. Thank you for your interest in this really important topic. And I would be happy to answer any questions. So I really enjoyed being able to tell you about what we've been working on.